A population of butterflies increase at a rate of 18% per year. In 2015, there were 500 butterflies in the park. Write a function rule for y when it's x years since 2015. So in your equation, x does not represent 2015. X represents however many years it's been since 2015. So in 2015, how many years have passed? Or how many years is it since 2015? In 2015, how many years has it been since 2015? 0, because it's 2015. If it was 2016, how many years has it been since 2015? 1. In 2020, how many years has it been since 2015? 5. So that's what x is going to represent. It's not going to be 2015, it's going to be 5 because it's been 5 years. It's going to be 0 because it's been 0 years. Okay? So, remember when we write our equations for exponential, it's always y equals the initial amount. How many butterflies were there in the beginning? 500. So it'd be 500 times. Now, this is the hardest part about exponential. Since it's increasing at a rate of 18%, I want to show you, if I type in y equals 500 times 18%, and remember you always have to change it to a decimal, move the decimal twice like we just talked about, and then raise to the x. If I graph that, when it graphs, does that look like it's increasing in the number of butterflies? If you hit second graph, you can look at the table. That's not increasing, that decreased. So remember, anytime it says something like increases at a rate of 18%, you have to use percentages and you have to think about percentages. So that's what I mean by this is the hardest part about exponential. If it was exactly the same every single year, what percentage of the butterflies would I have? If I had the same exact amount? 100%. So anytime something stays exactly the same, it's 100%. Now, if it's increasing by 18%, you're going to say 100% because that's normal. That's how much if it stayed the same. Now, increase means I'm going to add 18%. What is 100 plus 18? 118. So it would be 118%. Now I need to make that a decimal. So it would be 1.18. Now, this is a growth because this number is larger than 1. So then you know if I type that in my calculator, it's going to be a growth. Let me zoom out. So, come on, finish. Zoom, zoom, out. So notice you can see that it's growing. I still can't see the initial because the initial is 500, so I have to be zoomed way, way out to see that. I bet I'll see it this time. Yeah. So remember, or if you look at the table, oh, darn it, sorry, I hit enter again. I have to wait for that little icon to stop spinning. There we go. So now look at the table. Notice it's increasing. It went 500, 590, 696, 821. Does everyone see that? So that is an increase. That is a growth. It's growing every year. Okay, now, what if I told you to find how many butterflies were there? How many butterflies? Butterflies, man, I can't spell. In 2018. How many butterflies were there in 2018? Now, I'm going to use this equation. Now, that's the nice feature on your graphing calculator. It says how many butterflies in 2018. Do I need to move my calculator to an X value of 2018, or what do I need to use? The 3. Why the 3? Because it's been 3 years since 2015. You can subtract 2018 minus 2015, and you know it's 3 years. So how many butterflies would there be? 821.52. Can you have 0.52 of a butterfly? No, so it says round on your assignment today, or on the assignment, it's going to keep saying something like round to the nearest whole number, because you can't have half of a butterfly. So what is 821.52? Does that round up to 822, or does it stay 821? It rounds up because of that 5, makes that 2 round up. So it would be 822 butterflies. Okay, so there is that one. All right, now another reason we use exponential, and this is kind of the biggest reason you learn exponential. If you like exponential, or if you do not plan on going on to be an engineer, the financial literacy class that we offer as the senior, where you learn how to balance a checkbook. You learn how much does it actually cost you to buy that car that has 3% interest. So if you like that, you can always take financial literacy. It's actually the class that I suggest every senior takes, because I think every senior needs to know how to balance a checkbook, how much does it actually cost, and that stuff. So everyone is required to take 4 years of math. You have to do Algebra 1, Geometry, Algebra 2. Your 4th year is whatever you choose. You can take pre-calc, you can take elementary functions, or you can take financial literacy. I have taught financial literacy, and I think that it's the best class for seniors to take. All right, so that's why we do exponential. So this problem says the balance of a savings account is it's in the table. So if you look on the table, it says number of years and then the balance. So if I have 1 year has 110, 2 years has 121, 3 years is 133.10, 4 years is 146.41. And the question says, write a function rule that represents the balance after X years. So it says write a function rule that represents the balance after X years. So when we write our equations, y equals, remember it's always the initial amount times whatever is multiplying each time. Now, here is my question. What is the initial amount? Is it 110? Why not? You're saying no. Why not? 110 is after 1 year. You need to know after 0 years, after no time has passed. So in order to do that, we need to know how much is being multiplied each time. So watch this, and like I told you, you need a calculator. So this is how you're always going to do this. You're going to take 121 and divide by the previous term. So 110. What is 121 divided by 110? 1.1. Okay, let's just check that. So now take 121 and multiply by 1.1 and see if it gives you the next number. It did. Multiply by 1.1 again, and it's 146. So that is our multiplier. So I'm going to go ahead and type that in. It's write that down. It's 1.1x. Is this a growth or a decay? How do you know it's a growth? It's larger than 1. It's going 0.1. So what is that as a decimal or as a percent? How much percent is that? 110%. It's just like that last one we did. That means it's increasing by a rate of 10% each year. Okay? Now, let's find the actual initial amount. So I'm going to take 110. Do I need to multiply by 1.1 or divide by 1.1? You need to divide by 1.1 because you're moving backwards. So what is it? 100. It's 110. It increased by 10%. It was $100. So this, if you look, they started with $100 and it's increasing at a rate of 10%. You will never, ever, ever, ever find a savings account that gives you 10%. Usually, you're lucky for a savings account if you get 1% a year. And the reason why is that usually in finance, the more risk, the more reward. A savings account has no risk involved at all. Because if you know, they're all FDIC, federally, I can't remember the acronym, but it means they're backed by the federal government. If the bank loses all of its money, the federal government will help you and give your money that's in the savings account. So there's absolutely no risk.